Hello students, welcome back. Let us continue with exercise 12.2 of chapter 12, Heron's formula. We will be taking a look at the third question that reads, Radha made a picture of an aeroplane with colored paper as shown in the figure. Find the total area of the paper used. So, when we talk about an aeroplane, obviously the first and most important criteria is that it should be symmetrical. Symmetrical, that means when I draw a line of symmetry in the center, either halves on either side of the line should be equal in the dimensions. So, now this figure is composed of different parts. I have part 1, 2, 3, 4 and 5. So, the first part, if you can see, is a triangle. The second part is a rectangle. The third part is a trapezium. And the fourth and fifth part are triangles. So, how we are going to find the area of this figure? We are going to add the areas of these 5 parts to find the area of the paper used. So, the first part, how will we find the area? If you notice, this length is 5 centimeters. Obviously, this length will also be 5 centimeters. And this length will be how much? It will be equal to this length, which is 1 centimeter. So, let's mark this as 5, or rather we will draw the diagrams and do it one by one. So, this is going to be 5, this is going to be 5 and this is going to be 1. Let's go ahead and find the area of part 1. So, I will say solution. So, I will say finding area of 1. Now, in this triangle we have been given the 3 sides, so we are going to use the Heron's formula to find the area of triangle. So, first we need the semi-perimeter. The semi-perimeter is the sum of 3 sides divided by 2. So, 5 plus 5 plus 5, 5 plus 5 plus 1 upon 2, which is 11 upon 2, which is 5.5 centimeters. Right? Now, area of part 1 is what? 5.5 into 5.5 minus 5, then again 5.5 minus 5 and 5.5 minus 1, right. So, this is going to be 5.5 into 0.5 into 0.5 into 4.5, right. So, here we can see you have common terms 0.5 and 0.5. I am going to remove that common outside. So, 0.5 and I have 55 and 45 upon 100. So, I can write 5.5 as 55 upon 10 into 45 upon 10, right. So, let us split 55. This is 0.5 and one of the 10s will come outside. You have common terms here. So, 0.5 upon 10 into 55 can be written as 5 into 11 and 45 can be written as 9 into 5, right. So, here you have 2 5s and you have a perfect square 9. So, I am going to remove, this would be 0.5 upon 10 into 5 for these 2 5s and into 3, because 9 is a perfect square of 3 and you are left with under root of 11 inside. So, this will be how much? 5 3s are 50, 5 5s are 25, 25 into 3 is 75, 75, but we have 1 point. So, 7.5 root 11 upon 10. Let's find the square root of 11. So, how do you find the square root of 11? You have 11, you are going to mark this. So, 3 3s are 9, 2, I will add 3 here, I get 6, I add zeros over here and pair them up. So, this pair of 0 comes down. Now, let us check for 65 into 5. 5 5s are 25, 5 6 are 30, 32. So, 325. This won't work. So, I will take 64 into 4. 4 4s are 16, 4 6 are 24, 256. So, 63 into 3, 3 3s are 9, 3 6 are 18. So, 189 would work because it is less than equal to 200. So, it is less than 200. So, 63 into 3, so point here gives me 189 and I will add the 3 over here. So, I get 66, 1, 1 and I will bring down this 0. So 66 into what? 66 and another number into what will give me any number less than or equal to 1100. Let's check this. So 665 into 5 into 2. 2 2s are 4, 2 6 are 12, 2 6 are 12, 13. So 1324. This is not going to work because it's more than 1100, right? Let's check again. 2 2s are 4, 2 6 are 12, 2 6 are 12, 13. So I will have to take 661 into 1. 661. And I will add this 1 over here. I get 662. Subtracting, I get 9, 3, 339. So my root 11 is approximately equal to 3.31. So this is 7.5 into 3.31 divided by 10. Let's multiply 3.31 with 7.5. So 3.31 into 7.5. 5 ones are 5, 5 threes are 15, 5 threes are 15, 16, and 7 ones are 7, 7 threes are 21, 7 threes are 21, 23. 5, 2, 8, 4, 2. So this is equal to 24,825. And how many decimal places? 1, 2 and 3. So 1, 2 and 3. Here will be your decimal point divided by 10. So this will be equal to, now you have a 10 over here, so you're going to shift another decimal place towards the left. So you get 2.4825. So let's just take this as 2.48. So this is approximately equal to 2.48 centimeter square. This is the area of region 1 or part 1. So let's go and let us mark this because we might have to erase the board as well. So this is 2.48 centimeter square, right? Now we will go ahead and find the area of region 2, which is a rectangle. So you know that the area of a rectangle is what? Length into breadth. So here my length is 6.5 centimeters and my breadth is 1 centimeters. So area of region 2 is equal to length into breadth, which is 6.5 into 1, which is 6.5 centimeter squares, right? Let's even mark this as 1. So area of region 2 is 6.5 centimeter square. Let's mark this as 2. Now region 3 is a trapezium. So let's first take a look at region 3. You have each of these sides as 1 centimeter each. This side is 1 centimeter and this side is 2 centimeters. So if I draw a perpendicular like this, what do you think will happen? This side will become 1 centimeters. So out of 2 centimeters, I am cutting 1 centimeters. How much am I left with? I am left with 1 centimeters. Now that 1 centimeter is getting equally divided between these two parts. So each of these parts, which two parts am I talking about? This part and this part. Each of this part is 0.5 centimeters and 0.5 centimeters, right? And if you see each of these triangles, they are going to be equal in area. Let's take a look at just one of these triangles. So what do I have? I have this as 1 centimeters. I have 0.5 as the base, and this length was the perpendicular length, right? So this can be found out through Pythagoras theorem. So now for this trapezium out here, we have the height and we have the parallel sides. We know that the area of trapezium is half into sum of parallel sides into height. So what we need to find out here first is the height. So let's go ahead and first define what each section is standing for. So now finding area of 3. So now what we will do is we will draw the trapezium separately. So drawing 3 for clarity. And we will name this region. I'll call it A, B, C, D. So what we are going to do is we are going to draw AM and BN perpendicular to DC. So I'll say drawing AM and BN perpendicular to DC such that points D, M, N and C lie on a straight line. So these are perpendiculars. Now we had this entire length as 2. This is 1 centimeters, this is 1 centimeters, this is 1 centimeters. Therefore, you have MN is equal to AB, which is equal to 1 centimeters, correct? And DM is equal to NC, also DM plus NC is equal to DC minus MN, which is 2 minus 1, which is 1 centimeters. Right? Now since these two are equal and their sum is 1 centimeters, therefore I have DM is equal to NC, which is equal to 1 divided by 2. Right? 1 centimeters divided by 2, which is going to be equal to 0.5 centimeters. Or you can just leave it as 1 upon 2 centimeters. So let's go ahead and first find the height of triangle ADM or BNC. For our, we will just take ADM. Now, in right angle triangle, ADM, I have AM square is equal to AD square minus DM square through Pythagoras theorem. Right? So AD is how much? AD is 1 square and DM was how much? Over here, half. So this will be 1 upon 2 square, which is equal to 1 minus 1 upon 4. So 1 minus 1 upon 4 is 3 upon 4. Right? 3 upon 4 centimeters. But this is AM square. Students, I'm erasing this part of the board so that we can continue further. And let us even mark the area of part 2, which is 6.5 centimeters square. Okay, so moving forward, AM is equal to under root of 3 upon 4, which is equal to 3 upon 2. We know root 3 upon 2. We know that the square root of 3 is 1.732. So this will be 1.732 divided by 2. So 1.732 divided by 2. 2 8s are 16. 2 6s are 12. 2 6s are 12. So this would be AM, which is equal to the height, is 0.866 centimeters. So now this is the height of trapezium. Height of ABCD. Now area of trapezium is equal to half into sum of parallel sides into height. So which is your trapezium in this case? It is area of ABCD or area of 3, right? Which is half into sum of parallel sides. The sum of parallel side would be AB plus DC, right? Half into AB plus DC into AM, which is the height. So this is going to be half into AB. AB, as you can see, is 1 plus DC, this entire length is 2, into AM, we just found that to be 0.866. So 0.866. So this is going to be half into 3 into 0.866. So first let's multiply this 866 by, or rather what you can do is 2 ones are 2, 0, 2 fours are 8, 2 threes are 6, 2 threes are 6. So 0.433 into 3. So 3 threes are 9, 3 threes are 9, 3 fours are 12. So 1.299, which is approximately equal to 1.3 centimeter square. So why did I take 1.3 instead of 1.299? Because this number after 2 is greater than 5. If the number would have been less than 5, we would have just kept it as 1.2. But since this number after 2 is greater than 5, I am adding this up and making the value approximate as 1.3 centimeter square. So this is nothing but your area of region 3. Now we will go ahead and find the area of region 4 or 5 because both their areas are equal. But before that, let's mark the area of region 3 in the diagram. So I hope you have taken a note of that section because I'll be erasing it. Now, area of region or area of 4 is equal to area of 5. Why are these two areas equal? Because you can, if you can see, these are the wings of your aeroplane. The wings have to obviously be symmetrical. You cannot have one wing like this and one wing like this. Both the areas and dimensions have to be equal. The triangles also need to be congruent. Now, finding area of 5 or 4. Let's do it for 4. Or let's just find it for 5 because we have the markings on the board. So now this region is 1.5, this is 6, and you have this to be the perpendicular, right? If you see your triangle, this is the perpendicular. So you have the base as 1.5, you have the height as 1.6. So you can just do a half into base into height and find the area of this triangle. I'm sorry, this is 6 centimeters. So the base is 1.5 and the height is 6. This is the perpendicular, because whenever you're constructing your aeroplane, when you attach the wings, they are going to be perpendicular to the actual plane region. So I'll say area of 5, sorry, is equal to half into base into height, which is equal to half into 1.5 into 6. So this is 2 ones are 2, 2 threes are 6. 3 into 1.5, 3 fives are 15, 3 ones are 3, 4. So 4.5. So area of 5 is equal to area of 4 is equal to 4.5 centimeter square. Let's mark this as 3 and this as 4. Also, let's mark the areas on the diagram. So this is going to be 4.5 centimeter square and this is also going to be 4.5 centimeter square. So now what we are going to do is we are going to find the area of the plane by summing up the areas of parts 1, 2, 3, 4 and 5. So I'll say area of plane is equal to area sum of areas of 1, 2, 3, 4 and 5, right? So this is going to be equal to, the first part was 2.48. So 2.48 plus region 2 was how much? 6.5. Region 3 was 1.3 and region 4 and 5 each were 4.5. So 4.5 plus 4.5. So let's add these. 2.48, 6.5, 1.3, 4.5 and 4.5. So this is 0, 0, 0, 0. 8 plus all the zeros is 8 and 4 plus 5 is 9. 9 plus 3 is 12. 12 plus 5 is 17. 17 plus 5 is 22. So 6 plus 4 is 10, then 15, 19. So 19.28. So this is equal to 19.28 centimeter square. And here you can say from 1, 2, 3 and 4. Right? So finally we will write our answer. I'll say answer. Area of paper used is 19.28 centimeter square. So please take a look at the solution. I know this is not the entire solution because we had to erase the board because of lack of space, but please take a note of this. This is very important. When you get big sums like this, always mark your areas in a pencil or with a different colored pen so that it becomes easy for you to calculate towards the end. Thank you for watching this video.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.